Good day again, grade 7 learners. Welcome to our Math O'Clock with Teacher Catherine. Prepare your math modules and let us explore the world of mathematics. Let's go! You are now able to write sets using different forms as what we have discussed in the previous video. Let us now explore more concepts about sets, which are subset, universal sets, null set, and the cardinality of sets. We will also be having a short discussion on the different types of sets. After going through this video, you are expected to first illustrate a subset, a universal set, null set, and cardinality of set, and next is to determine the subsets of a set, and lastly, to determine the cardinality of sets. Are you ready? Let's start. Let us have the first, the universal set. The universal set U is the set that contains all objects under consideration. In other words, universal set is the mother set of the sets that we are dealing with. Here are examples of universal set. 1. Set U, or the universal set U, which contains the set of whole numbers. So the elements of which are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. Take note that when we are talking of whole numbers, 0 is included. For number 2 example, we have the universal set which contains the set of all letters of the English alphabet. So its elements are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And when dealing with letters of the alphabet, it is automatic that the universal set is the set of all the letters in the alphabet. For number 3, the universal set U, which contains the set of days of the week. So the elements of which are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So as we can see, each universal set contains the complete elements of the rule or characteristic under consideration. Let us now have the subset. So from the prefix sub, this is an aggregate of the set. Given any two sets A and B, if every element in A is also an element in B, then A is a subset of B. The symbol for set is the letter U, which opens to the right and with a line below it, which is read as A is a subset of B. We have to take note also that every set is a subset of itself, and an empty set is also a subset of every set. Let us now have the following example. So given set R be the set of 1 and 2. Since it is stated a while back that the set is a subset of itself, the first subset that we will list is the set itself. So we have the set 1, 2. That is under the two elements. Now let us start listing subset with one element. We write the elements 1 and 2 separately. So that is on the second column as you can see. Lastly, always write an empty set. An empty set is always a subset of any set. All in all, we have 4 subsets. Let's try to write the subsets of set O with elements red, blue, and yellow. For the first subset, we copy the given set, red, blue, and yellow. That is what is written in the first column. For the next column, using organized listing, combine two elements. So we have red and blue, red and yellow, and blue and yellow. Then we write the elements individually. We have red, blue, and yellow. Lastly, do not forget the empty set. So we have 8 subsets. Now, let us try to analyze the relationship of the numbers of elements and the number of subsets in a set. If we have 2 elements, the number of subsets is 4. If we have 3 elements, 8 subsets. If we have 4 elements, we will be having 16 subsets. So as we can see, there is a pattern, right? The number of subsets of a set can be obtained by the formula 2 raised to n, where n is the number of elements. Amazing, right? You may also try other examples to prove this. We will now be mo- we will now move to empty set, or sometimes it is called the null set. A set that contains no element is called an empty set or null set, and the symbol for empty or null set is braces with no elements inside it, or you can just draw a circle and then write a slash. The following are examples of null set or empty set. 1. Set T is the set of counting numbers between 1 and 2. There is no counting number between 1 and 2 because they are already consecutive counting numbers, so it is null. Second is set I, which is the set of months with 35 days. Can you name a month of the year with 35 days? Alright, none. So it is null because there is no month in a year with 35 days. Next, number 3, set M is the set of cars with 60 doors. As of record, there is no car with 60 doors. Therefore, that is an empty set. Take note, dear learners, if we have null or empty set, just write braces or the circle with slash. Do not put 0 inside the braces. Once an element is written inside the two braces, it is no longer empty. We now have the cardinality of sets. A while back, in the discussion of subsets, we've been counting elements. Counting of elements has something to do with cardinality of sets. The cardinality of set A, denoted by n of A, is the number of elements in set A. Take note of the symbol, okay? If we have n, then parentheses, and then the name of the set, we are referring to cardinality. For the first example, the set of vowels in English alphabet, the elements of set D are A, E, I, O, and U. Let us count the elements. 1, 2, 3, 4, and 5. Therefore, the cardinality is 5. For number 2, set R is the set of letters in the word difficulty. Let us list the elements: D, I, F, C, U, L, T, and Y. Take note that similar letters are only written once. Counting the elements, the cardinality is 8. For empty set, like the set of odd numbers between 1 and 3, the cardinality is 0. Now, for additional info, let us also discuss the different types of sets. The first type is the finite set, which is a set having a limited number of elements. That means that the elements are countable. Examples are set A with the elements 1, 3, 5, and 7. So the cardinality of which is 4. We also have set B, which is the set of even numbers up to 100. So still, although we have here an ellipsis, we have a last element which is 100, which states that this set is finite. Take note that not all sets with ellipses are infinite. Okay? So let us now move to infinite set. Infinite set is a set having an unlimited number of elements. For this set, it is impossible to count and list the elements. This type of set uses ellipses at the end to represent the sets. An example is the set of natural numbers, which is continuous. We also have equal sets. Two sets are said to be equal if they contain exactly the same or identical elements. The sets S and T are equal because the elements are exactly alike. So the elements for set S is P, Q, and R, and the elements for set T are Q, R, and P. Even if the arrangement of the elements are not the same, as long as the elements are alike, they are equal. Lastly, we have equivalent sets. Two sets are equivalent if the number of elements in both sets are equal. Sets C and D have different elements, but their cardinality is the same, which is 5. Therefore, they are equivalent. So easy, right? If you have any questions, just PM me or just consult your teacher. At this point, we will now be ending your class or this session. So, learners, class dismissed. So, congratulations for a job well done. Dear learners, you may now apply what you have learned by answering the activities on your module. Thank you for watching. Do not forget to subscribe to our YouTube channel for more exciting lessons in Math 7. Until next time, goodbye!